right.
On graph A here, what are these zeros that we've got? -4 right here. -1 right here. And a +3. And what did you say about -1? It is a double root. So I have zeros of -4 and 3 of multiplicity 1. Thank you, sir. And -1 that has multiplicity 2. Multiplicity is the same, if I have a multiplicity of 2, same exact thing as a double root. All right, so initially in factored form, do I have my leading coefficient here? No. Then I need a placeholder for that. So I have f of x equals a times x plus 4 times x minus 3 times x plus 1 squared. So far, so good? All right. We're supposed to find that leading coefficient. What information did they give me that I can use to find that leading coefficient with? They gave us a point. We can sub this in to find our leading coefficient of a. So I'm going to put -8 in the place of f of x. And I'm going to put 1 in the place of x. So I have 1 plus 4, 1 minus 3, and 1 plus 1 squared. 1 plus 4 is going to give me what? 5 times 1 minus 3. -2. 1 plus 1, 2, squared. 4. What do I get when I multiply all of these together then? -40. So that's what I'm going to need to divide this by to find a. Negative divided by a negative means I know I have a positive leading coefficient, which I could tell from the graph. How did I know the leading coefficient had to be positive? Yep, right side's going up, so I know it has to be a positive leading coefficient. What do we know about the degree? Has to be an even number. I'm guessing it's probably 4. Has to be at least 4. It could be a higher degree, but probably degree 4. Has to be even. What is our a value here? 1/5. Yes, 1/5 for our a value. So now I'm prepared to write the equation for this graph, or a possible equation for this graph. F of x equals 1/5 times x plus 4 times x minus 3 times x plus 1 squared. And again, the order that you put your factors in does not matter. That 1/5 does have to be at the very front since it's your leading coefficient. But the remainder of those factors, if you mix up the order, as long as you have all those pieces, I don't care what order they're in, it does not matter. All right, I'm going to write a couple notes to ourselves. We knew from over here that we had a positive leading coefficient, and I knew from the fact that both ends went up that this had to be an even degree. Are we even or odd degree on the next graph? Odd degree. How do we know that? Yep. My ends are opposites. Positive or negative leading coefficient? Positive. Right side goes up. So positive leading coefficient. I always try to get some notes to myself based on the other things that we've learned so far so that as I'm doing this algebraically in a moment, if I get something, it should match what I know about it in the beginning. What are these zeros that we have here? We have 2, 0, double root here. What else? -1. And -3. Looks like they're counting by 0.5s on that x-axis down there. Okay, we have a 0 at 0 with multiplicity 2. And we have -3, -1, and 2 with a multiplicity of 1. So what I've got so far, f of x equals, if I have a root at 0, what is my factor? Just x. Since it has a multiplicity of 2, it's going to be an x squared. And then I have x plus 3, x plus 1, and x minus 2. What degree are we at right now? Degree 5. It's an odd degree, so I've probably got all of my factors covered here. What did I forget? A. We have to put our placeholder of A in there because we do not know what our leading coefficient is yet. What information do I have that I can use to find that leading coefficient? They gave us this point, -216. We will sub in to find our A value. So 16 goes in the place of y, my function notation, equals A times -2 squared times -2 plus 3 times -2 plus 1 times -2 minus 2. -2 squared? 4. -2 plus 3? 1. -2 plus 1? -1. And -2 minus 2? -4. Multiply all those together and I get positive 16. So that's what I have to divide over here to find A, which means A is 1. So a possible function rule for this graph, f of x equals x squared times x plus 3 times x plus 1 times x minus 2. Do you guys have any questions for me at all? Yes, ma'am. Does it have to be in the front? No, it does not. It also does not have to be inside parentheses since it doesn't have a plus something or a minus something with it. So even if you stuck it in the middle or at the back, you're welcome to put parentheses around if you want it, but it's not required. Any other questions? There is one last thing that we need to cover in 4.3. It is called Descartes' rule of signs. His name is French, so when I put it up on the screen and you see it spelled out, it's going to have a lot more letters than we actually pronounce. Descartes' rule of signs tells me how many potential positive real zeros and negative real zeros I could be looking for in a function. And then using what I know about those positive real zeros and negative real zeros and the degree of the function, I can figure out how many possible non-real or imaginary zeros this would have. So a couple things that I want you to notice. F of x has to be a polynomial function with real coefficients, and it has to have a non-zero constant term. If this is a function that has a y-intercept of 0, I can't use Descartes' rule of signs. It has to have a non-zero constant term. The number of positive real zeros of this function is either equal to the number of variations of sign, so when it goes from being positive to negative, or when it goes from being negative to positive, looking at those terms. So it's either equal to the number of variations in sign of f of x, or it could possibly be less than that number by an even integer. What do they mean by an even integer? Give me an example of an even integer. 2. 6 would be an even integer as well. We're going to be using 2 here. Technically 0 is an even integer, but if I subtract 0 from something, does it change? If I subtract 2 from something, it will change in value. I'm going to give you an example of what this looks like. So if I have a function f of x, and f of x is x to the 5th minus x to the 4th plus x cubed minus x squared plus x minus 1. Still 4.3, yes. I want to count when the terms in f of x change sign. So the very first term, what is my leading coefficient? Is it positive or negative? It's a positive 1. So I start off with a positive term. The second term in this is a positive or a negative? Negative. That would be a change in sign that I want to count. It went from being a positive term to being a negative. So I'm going to count that as 1. So far there is 1 change in sign. Second term is negative. What about the third term? Is the third term positive or negative? Positive. It changed. It changed from being a negative, now it's a positive. So now I have 2 changes in sign so far. So far, so good? Third term is a positive. Fourth term is... What's my fourth term? Negative. I have another change in sign here. So far I've had 3 sign changes. Fourth term is negative. Fifth term is positive. So I have another change in sign here. I'm up to 4 sign changes so far. Fifth term is a positive, and my very last term, my constant, is negative. So I have another sign change here. So there are 5 total sign changes. If the term in front of it has a different sign, I count that as a sign change. If they have the same sign, and we'll look at that in a minute, I would not count that as a change until it goes from being a positive to a negative, or from being a negative to a positive. Since there are 5 total sign changes here, there are possibly 5 positive real zeros or, so the maximum number of positive real zeros is 5. Take that down by an even integer. What did you tell me a nice even integer was? 2. Take it down by 2.
3.
There could be 3 positive real zeros. So there's or 3 positive real zeros. Can I go down by an even integer again?
Yes. Another 2. 1.
There could be 1 positive real zero. Can I go down any more? No, I can't have -1 zeros. That doesn't make any sense. So we're only working with like positive whole integers here. There could be 5 or 3 or 1. So that's half of Descartes' rule of signs. The other half of Descartes' rule of signs tells me about the negative real zeros of f of x. This time, it's going to be equal to the number of variations of sign in negative, or f of negative x, or less than that number by an even integer. So I'm going to have to substitute in and then look at my sign changes. Yes, sir. Yes, you may. So I have to substitute in negative x here. So I have negative x to the 5th minus negative x to the 4th plus negative x cubed minus negative x squared plus negative x minus 1. Yes.
Would we just be able to list them like 5, 3, 1, and then possible real zeros?
We're going to make a table here. We need this information, and then we'll make a table that is going to list them just like you said. Absolutely correct. And I'll show you why making a table is probably the most straightforward way to do that. If I take a negative input to an odd power, what kind of output do I get back? I have a negative value to an odd power. I get a negative output here. So I'm going to have a negative x to the 5th. Bring down my subtraction sign here. What about if I have a negative input to an even power? Positive. So it's just going to stay the same. This is going to be minus x to the 4th. What's going to happen here, though? I'm going to have a negative input cubed, so it's going to come out as a negative. If I add a negative number, that's subtraction, right? So this is going to be minus x cubed. Bring down my subtraction sign here. If I take negative x and I square it, stays the same. Yeah, it's going to be a positive output, so it's just going to stay the same. It's going to keep its original sign. What will happen here? It's going to change. That's going to be a minus x, and then I bring down my minus 1. Is my leading coefficient a positive or a negative? Negative. So comparing the first term to the second term, it's a negative and a negative. Did I change? No change here. What about from the second term to the third term? No change. From the third term to the fourth term? No change. They're all negatives. Is there any sign changes anywhere in here? Every single term is negative here. So there are no changes in sign. So how many possible negative real zeros do I have? Absolutely correct. I have none. There were no changes in sign, and so I have no possible negative real zeros. What'd you say, dear?
Does that mean there's 5 possible real zeros?
No, but we'll talk about that in just a minute.
So that means there's 2 like imaginary. So do we have to do the chart because the chart was like confusing?
This is a different chart.
Then like the one that's like positive, negative, and then like imaginary.
Yeah, that's. Well, we're going to do positive, negative, imaginary, but we're going to look at all the possible arrangements. All right, so I'm going to make a table here to figure out all the possible things that could take place here. For positive real zeros, what were our options? We said there could be as many as 5, or there could be 3, or there could be 1. How many possible negative real zeros did we have? None. So if there's 5 positive real zeros, there's still no negatives. If there's 3 positive real zeros, there's still no negatives. And if there's 1, there's still no negatives. And then we have non-real or imaginary. We're going to have to work backwards and fill in the blanks here. I know that the number of roots I have, the number of zeros that I have, always has to add up to what? Starts with a D.
Degree.
Has to add up to the degree. What is the degree of our polynomial? 5. So all of these columns have to add to 5 because my degree of my polynomial is 5. Well, if I have 5 positive real zeros and no negatives, how many imaginaries? How many non-reals? 0. Because when I add these 3 numbers together, it has to add up to my degree. So far, so good? If there were only 3 positive real zeros, we still have no possibilities for negative real zeros. So if there were 3, how many non-reals would we have to have then? 2. Because my column has to add to 5. It has to add to my degree. If I only have 1 positive real zero, how many imaginary, how many non-real roots would I have to have? I would have to have 4. So there are 3 possible arrangements. This one, or this one for this polynomial. 3 possible arrangements spelled it too big. For the zeros of f of x. It's got to be one of those 3. There are no other possibilities. It's either got 5 positive real roots, so 5 things on the positive side of the x-axis, or it has 3 positive real roots and it's got some kind of a wiggle in there up off the x-axis, or it has only 1 positive real root and 4 imaginary roots. The reason we're always decreasing it by an even integer is my non-real, my imaginary roots, always have to come in positive negative pairs. If 3i is a 0 of the function, negative 3i has to be. Complex roots, not just complex, imaginary roots, non-real roots have to come in pairs. It is not possible to have a single imaginary root. So far, so good? All right. Let's practice with this right here. We're going to look at a couple more examples practicing Descartes' rule of signs. So first thing I want to know is the number of possible positive real roots. I can just look at the function and I'm looking for whether or not the sign changes. My leading coefficient is positive or negative? Positive. So between the first and the second, do we have a sign change? Yep. Between the second and the third, do we have a sign change? Okay. Between the third and the fourth, do we have a sign change? Yes. So there is possibly 3 positive real roots, or there could be, not 2, 1, because I go down by 2. 3 or 1 positive zeros. We're just looking for when it changes from being a positive to a negative. This was a positive leading coefficient. The next sign was a minus, so that's different. It went from being positive to negative. Then I look between this one and this one. The signs are different, so that would be another change, another variation. From being a plus to a minus, I have one last variation here. Now we're going to substitute in negative x. We're going to simplify, and then we'll go through and count again. So I have 4 times negative x cubed minus 6 times negative x squared plus negative x minus 3. Negative x cubed. Will my output have the same sign or the opposite sign?
Same.
If it's a negative x cubed, if I take something to an odd power. Sorry, I'm just looking at this first term and just simplifying that. I'm not looking at anything else here. It's going to come out negative. I'm going to have a negative 4x cubed here.
Oh, yeah, I thought I was thinking the same.
Yeah, no, I apologize. I realized as soon as you guys started answering that I had asked an unclear question. So I would have negative 4x cubed here. What about this term? It's going to keep the sign that it had, because this is going to be the same as just x squared times this front piece. So this is going to stay minus 6x squared. What about here? That's going to be a negative. So I have minus x. And then this stays the same, so minus 3. Do I have any variations, any changes as I look from term to term? Nope, no changes. So what does that mean about the possible negative real zeros? None. No negative real zeros. All right, so I'm going to make my table to help me figure out all the possible arrangements there are. We've got positive, negative, non-real, and I know it has to add up to my degree. For positives, we have how many options? I have 3 possible real zeros or 1. What about my negatives? No negative real zeros. What is our degree? Degree is 3. So if there's 3 positive real roots and no negatives, how many non-reals would there be? 0, because it has to add up to my degree here. If there is only 1 positive real root, how many non-reals would we be required to have? 2. So how many different possible arrangements could we have with this polynomial? two different possible arrangements. Those two possible arrangements are that we have 3 positive real roots or there's only 1 positive real root and 2 non-real roots.
Can you just tell by the graph, or do you actually just write this stuff out?
I mean, do you have this graph?
Huh?
Do you have this graph?
I mean this one. The chart.
Oh, you're talking about, sorry, you said graph, and I was like, I mean, you can tell by looking at the graph, but we don't have a graph, so. So we're going to be using this information, but I can tell you on the homework that's due, I did bump that due date out since we're not finishing till today. On the homework, it has like all the possible different things, and you have to select the ones that are true. Use your chart to figure out which ones are correct.
Okay, but on the test, it's not going to be like that. So if you want to write them out.
On the test or the quiz, if you have this, I see all the possible arrangements there are. The number of columns would be all the possible arrangements you've got. So this would be sufficient for me. I do want to make sure that you know what this means and that you could write it out in words or you could recognize it written out in words. Does that sound fair?
Yes.
Okay.
So makes sense.
Let's look at B. Let's just count up the possible positives right now.
I think you do. Just making it.
What are the possibilities for the positive real roots? 3. Because I go from positive to negative, from negative to positive. Here's positive to positive, so I don't count that. That's not a change. Yes, ma'am.
If you're using, you know how you like subtract by 2?
Mm-hmm.
If you have 2 possible outcomes, you can subtract by 2 and get 0, right?
Yes. So I've got one change here where it goes from positive to negative. I've got another change here where it goes from negative to positive. Where's my last change?
That's what I was doing.
Right here is my third change, but then these last 2 are both negative, so that's not a change. That's not a variation in sign. So there is possibly three or 1 positive real zeros. You all, like when you count your sign changes, that's the maximum, and then you always have to subtract 2 until you can't subtract 2 anymore because it would give you a negative. So 3 or 1. Then we're going to substitute in with negative x. We'll simplify, and then we'll count those sign changes. So 3 times negative x to the 7th minus negative x to the 4th plus 3x cubed, 3 times negative x cubed plus 2 times negative x squared minus negative x minus 3. My first term, how will that simplify? Negative 3x to the 7th, because we have an odd power. What about my next term? Negative 4x to the 4th. It will stay the same because it's an even power. My next term? Negative 3x to the 3rd. Next term? Plus 2x squared here. Plus x, and then minus 3 on the end. How many changes in sign do you see? 2. Negative to negative, those aren't changes. Negative to positive is a change. Positive to negative is another change. So there is possibly
I used to, and I don't
2 or 0, because I can go down by an even integer and it's possible for me to have no negative real roots. All right, so now I'm going to make my table. I've got positives. I've got negatives. I've got non-real. And that is going to have to add up to my degree. What is the degree of this polynomial? 7. What is the maximum number of positive real zeros, we said? Maximum number of positives, 3. Or we could have had 1. So I'm going to start right here. I know we've got some options for our negatives, but I'm going to start right here. Let's just assume for a minute that we have 2 negative real zeros. I could have 3 positives and 2 negatives, which would mean how many non-reals? 2, because it has to add to 7. I could have 1 positive and 2 negatives. How many non-reals would I have then? 4. Please pay attention to this one. This is where we have multiple options for positives and multiple options for negatives. I can have 3 positives and 2 negatives. I can have 1 positive and 2 negatives. Now hold on, I'm not to that one yet. My positives, the maximum number, and then this one, could also have 2 negative real zeros. What was the other option for my negatives? 0. I could have 3 positives and no negatives. I could have 1 positive and no negatives. Still has to add up to 7. If there are 3 positive real zeros and no negative real zeros, how many non-reals? 4. If there is only 1 positive real zero and there are no negative real zeros, how many non-reals would we have to have? 6. So how many different possible arrangements do we have? 4. 1, 2, 3, 4 possible arrangements for the zeros of f of x. Both of these could go with this. Both of these could go with that. So 1, 2 arrangements here, 1, 2 arrangements here.
God's gonna be sucking when there's 5.
You are not wrong. Why do my non-reals have to be even again? They always come in pairs. I want you guys to try this last one on your own, and then we'll stop here for today. We'll start 4-4 at the very beginning of class tomorrow. Try that last one for me. Yes.
So is that problem different where you don't have to add the 2 zeros?
What do you mean have to add the 2 zeros?
Because like there were 2 sign changes for negative, right?
Mm-hmm.
So then why didn't you just put 2 zeros? Does that make sense?
Because then you're leaving out 2 possible arrangements. If there are 3 positive real zeros, that doesn't tell me anything about how many negative real zeros you could have. So I could have 3 positives And I could have 2 negatives. I might have 3 positives, and I might have no negatives. So those are 2 distinct arrangements. I know the number of positives. I know the number of negatives. There's 2 options there if I have 3 real zeros, or 3 positive real zeros. If I only have 1 positive real zero, I still have 2 options for my negatives.
So, okay, so it's just that there's more.
Yes, you're going to have more. If you have multiple options for your positive and multiple options for your negative, you have to match up all the possible things that could happen. And that'll be how many columns you have.
And then can you also have one where there's 6 non-real? Like let's say all columns, or I'm for this one to be 7. All columns had like positive, negative, or 0, and non-reals at 7.
So if we were, say, a degree 6, and my positives came out to be 6, 4, 2, or none, and my negatives, let's just imagine that we have the same thing, 6, 4, 2, or none. Is it possible that all of my zeros are non-real? Yes. It's possible that you have no positives, no negatives, and all non-real roots.
Okay.
This rule,
Mm-hmm.
for letter A, you said there were no changes in sign, but you have 4.
Negative 4x cubed, and then a negative 6x squared. That's not a change because they're both negatives. Yeah.
Yeah.
How many changes in sign do we have for f of x? 1 change in sign right here. So there has to be 1 positive real root. That is the only option. How many negatives are possible? Was it 3 or 1? 3 or 1. So my non-reals would be 0 or 2, because it has to add up to a degree of 4. Nice work today, guys. We'll begin 4-4 tomorrow. 4-4 or 4-3 homework is due tomorrow night.